Okay, this is just a very quick glimpse of where I am on my side of things. So, this is the VB simulator that interfaces with the C++ DLL that does all the physics. Running it now. As you can see, it's a bit of a Swiss Army knife. Um, it's the OpenGL window. You can see everything's to scale. Got some debugging lines. So as you can see, it tracks the correct uh, cell in the table for the aerodynamic numbers like the CD, the CL, and the LD ratio. What I wanted to show you was this. Um, so this will track the space plane and keep the space plane in the center of this square. I haven't added the code in yet, but and the space plane on the right over here is going to show the pitch. So if yeah, just ignore what's going on here for the moment. I'll fix all that. So if I accelerate time, you will see that the pitch will increase. As you can see, the pitch is already increasing. This combo box is showing the pitch, which is half a degree above the artificial horizon. So let me accelerate time. Accelerate time. Okay, accelerating time. You can see the pitch is increasing. So we got a sort of um, pitch indicator here. Yeah, that's not a pitch indicator. Don't get confused. Although I'm thinking of making like a proper um, pitch indicator, like as if you're in the cockpit, but that's a low priority. That's something I'll add on after I've done everything else. And so we got a way to track the pitch of the aircraft. That's the aircraft, but I haven't added the graphics in yet. But as you can see, it's bouncing on the earth. Um, so the next thing I've got to do is, because at the moment, even though it's tracking all the right numbers from the table for aerodynamics, I haven't actually coded in the physics for the atmospheric interaction yet. So at the moment it's in a vacuum environment bouncing off the earth, but it's extracting the correct um, coefficient of drag and coefficient of lift according to the angle of attack and the Mach number. And as you can see, the angle of attack and the pitch, they're similar, but they're not exact. They're similar, but they're not exact. And eventually they'll deviate as the aircraft gets to the other side of the planet, which I'm not sure it's gonna be able to make it. Let's see what happens if I accelerate time some more, just to demonstrate that the pitch and the angle of attack are not the same thing, that they'll deviate. So as you can see, they're not the same anymore. Angle of attack is 13. The pitch is like a full degree or two ahead of it. And if you look at the OpenGL window, we will see why. Because the aircraft is now over here. Yeah, I gave it a very small initial velocity. So it's like a cannonball bouncing off the earth. So the angle of attack should be a lot higher than the pitch when it's on its way down. See, that is a full 2 degrees now above the pitch, and now because it's bounced and it's going up, it's got re, in reverse AOA. And here we go again. So on its way down, it's 16 degrees angle of attack with 14 degrees pitch, and on its way up is 12 degrees, so 2 degrees plus minus the pitch, and the pitch doesn't change when it's bouncing. Yeah, it's constant, so that makes sense. So I'm not convoluting the angle of attack with the pitch. They are different. So hopefully that proves that the programming is solid, that bugs. I'll get back to it now. So oh yeah, so here here as you can see we track the spacecraft above different points of the Earth. But in the other window, what happens is the Earth moves underneath the spacecraft, different frame of reference. So the ground is moving, but you can't see it. But with this projection, with this relative view, the aircraft will always be above the Earth and the ground will always be level, unlike the OpenGL window, where the Earth is on an angle. Uh-oh, what's happened? Yeah, you see that? The Earth is on an angle because it's like 10 degrees from where it started. Oh, and you see this blue axis and green axis that's tilted? That's because I accelerated time and the Earth was rotating. So yeah, it takes into account of the Earth rotation as well. But like I said, in this window, yes, the Earth is still rotating, but but the ground is constantly moving underneath the center of the screen. Hope that makes sense. Yeah. Anyway.